Could you elaborate? I didn't know that uranium-235 could be concentrated enough in water to go critical. That's kind of crazy. How does that happen? Well, let's start off with the basics. To begin with, an element is defined by the numbers of protons in the nucleus. With uranium, it's got 92 protons in the nucleus and 92 electrons in clouds surrounding it. And it's those electron clouds that define the element. That defines how it interacts with other elements, those electron clouds out in the orbitals. Now, the nucleus can have different numbers of protons. So even though all uranium has 92 protons, there are different isotopes, so that uranium-235 has 143 neutrons, whereas uranium-238 has 146 neutrons. And so those different numbers of neutrons in the nucleus give it different nuclear properties. So that uranium-235 is fissile, meaning that a thermal neutron, a slow neutron, can cause it to fission and give off a few hundred mega electron volts of energy on that one fission. Whereas uranium-238, the more common isotope, over 99% of all uranium in nature, is this non-fissile uranium-238 that will not fission with a thermal neutron. It's got to have a really high energy neutron, a few MeV, in order to get that to fission. So it's not considered fissile. Now, to make matters worse, the probability of fission is a function of the energy of the neutron. So that by the time a neutron gets really, really slow, the probability gets really, really high that fissioning will occur. Whereas with a faster neutron, the probability is not so high. And so when we put uranium in water, the water acts as a moderator. Basically, the protons in the hydrogen give rise to slowing down the neutron. Those protons in the hydrogen will collide with the neutrons in basically kinetic elastic collisions. So just like two two billiard balls coming together, a neutron can literally give off all of its energy into a proton and become thermal in one scatter. Now, on average, it will only lose about half of its energy in these scatters because neutrons and protons have almost identical mass. And so it's just like billiard balls scattering. And so as the neutron scatters around in the protons that you find in water, it will thermalize very quickly and make the probability of fission of uranium-235 quite high if the uranium is there mixed in with this water. Now, as a result, there is a minimum amount of this uranium that you're going to have in there, and there's a minimum amount of poisons that you're going to be allowed to have in order for it to go critical. And so by changing these mixtures in, say, a nuclear reactor, we can control the reactivity and allow ourselves to have a controlled chain reaction in a nuclear reactor. But those are the physics that hopefully answer the question. And let me know if I didn't answer it. Thanks for watching. Have a good day. Bye.